All right, so this week we are taking a look at sections 5.1, appendix 4, which is A4, and 5.3. So we're going to split those all up into a couple days for each section. All right, so today is just the first part of 5.1, and it's on what we call polar coordinates. So up until now, the way we've always looked at a coordinate is an x value and a y value. Right? In this case, right 2, up 3, and there you go. There's your point. Another way we can graph coordinates is on a circular kind of grid. Right? And a circular grid makes it very easy to draw certain shapes, okay, like circles. So let me show you, if I wanted to draw a circle on the graphing calculator, and let me draw it using the old kind of coordinates, okay, using what these are called rectangular coordinates, x and y. It's the ones we're familiar with. So if I want to do a circle, let's pick a circle of, let's make it a radius of 3. First of all, does a circle pass the vertical line test? Meaning if you draw a vertical line, does it only hit it once?
No.
No, it hits it twice. So I technically can't even draw a circle. The only way I can kind of do it is do the top half and then do the bottom half as a separate one. So I have to kind of do it as 2 halves. So a circle with a radius of 3 would look something like this. Okay. And that's the top half, and then this would be the bottom half. All right, and you'll see it as 2 halves because they're going to be different colors. And if I do zoom 5, let's see. Let me see. Let's try zoom 6 first. I might have been zoomed out too much. Now let me do zoom 5 now, so I can make it look more circular. And that's as good as I can do. All right, so that's, if we want to draw a circle using the kind of coordinates we're used to, that's as good of a picture as you get, which isn't even really that good. And you had to type in all of that to get the picture. So there's a lot of stuff we have to type in. Now, I'm going to try to draw a circle not using what we call function coordinates, but using polar coordinates. Okay? I'm going to draw the same size circle, radius of 3. That's it. So I type in a single number. And let me adjust it so it goes a little faster. Okay, so let's put this here and let's go radius of 3. Graph. Okay, I'm not sure why it is taking so long. Let me pause this. All right, so after adjusting a couple things in our window and hitting graph, now you can see we get a circle with a radius of 3, and it actually does look like a circle, and look at how simple it was to type it in as an equation. All I had to do was type in the single number 3 versus typing in all this stuff, and it didn't even look like a circle. So the point of this system we're going to learn about today is there are certain shapes that are a lot easier to draw in this system than the system we're used to using. Even though the system we're used to it's really good for some things. It's great for lines, like y equals mx plus b. You can draw lines really good in the system we're used to. Lines are not easy to draw in the new system because the new system is made more for things that are circular. We don't really even get into graphing an entire picture, but what we get into is graphing just a single point, just a dot. Right? But if you start putting in other things, you get all kinds of pictures, like this one. This is more of like a spiral. I'm going to zoom out enough so you can actually see it. You can see now it's kind of starting a spiral. So that's a picture that we couldn't get in function notation. Another kind of picture I could do, let's do like cosine 4 theta. Let's do zoom 6. Let me zoom in so you can see it a little better. Looks kind of like petals of a flower. So again, that's another kind of picture we definitely couldn't get in the system we're used to using. There's all kinds of neat graphs you can do in Polar that we've never even seen before. Yeah. All right, so now let's talk about what a polar coordinate looks like. So that, when you have an x and a y value, that's called a rectangular coordinate. What we're going to look at is what's called a polar coordinate. In polar coordinate system, first of all, it uses a different kind of graph paper. Right? The graph paper it uses is circular. There's only one axis, and that's called the polar axis, and it is horizontal. Generally, there's no other axis. I know we're used to having two, like an x and a y. But in polar, they just use the one. The point right in the middle, you can still call it the origin, but a lot of times they call it the pole in polar. All right, so that's the kind of graph paper we're going to use. And we're going to end up talking about how much you rotate around the circle when we describe the coordinate. That's going to be part of the coordinate. That's what a coordinate looks like in polar. It still has two numbers, but it's not an x and a y. It's an r and a theta. Here's an example with numbers right there. That's a polar coordinate. 3, 120 degrees. So in polar, the first number is called the radius, and the second number is the angle. So the way we're going to describe a coordinate on this circle is not moving left and right and up and down. That's rectangular. We're going to describe it as how far out we move from the origin, or the pole, and then how many degrees we rotate. That's polar. So the first number you look at is the r. And to graph that part of the coordinate, you're going to move out the number of rings indicated by r. Now r can be one of two kinds of numbers. R can be a positive number, like it is in that case, or it can be a negative number, like it is in that case. Whether it's a positive or a negative, that makes a difference. If r is bigger than 0, if it's positive, you're going to move to the right. Okay, so if r is positive, you're going to start by moving to the right. How far to the right? Well, whatever r is. If r is 3, then you're going to move out 3 rings. If r is 5, you go out 5 rings. And you can go in between as well. Like if r was 2.5, you can go in between the second and third ring.
Wait, so how could it go negative?
So negative would mean to the left. So it's not that it's negative distance, it's because negative distance doesn't really make sense. The negative just indicates a direction. So in that sense, r is kind of like x. You either start out going to the right, a certain number of units, or to the left, a certain number of units. Now, whether you go right or you go left, you then have to rotate a certain number of degrees. Now, when we talk about rotating on a circle, what are the two directions that you can rotate on a circle?
Clockwise and counterclockwise.
Clockwise and counterclockwise. And that's what positive and negative is going to tell you for the angle. It's either clockwise or counterclockwise. If your angle is greater than 0, you're going to rotate counterclockwise. That's that way. So positive angles rotate counterclockwise. And which way do you think negative angles are going to go?
Clockwise.
Those are going to go clockwise. Yep. That way. So you always do step 1 first, move left or right, and then after you do that, from that point, you're going to rotate clockwise or counterclockwise. So we're just going to practice graphing a bunch of points now. As I said before, we never really get into graphing full pictures. It's just not something we quite get to. But we'll graph single, just dots. All right, so let's try that. 3, 120 degrees. 3, 120 degrees. All right, so the first number we're going to look at is the 3. That tells me how many units I need to move out from the pole. And how about, because 3 is positive this time, we're going to start by going 3 units. Connor, which way? 3 units to the
right.
To the right. So what I do sometimes is I just put a temporary mark right there. I'll erase that in a second. But I'm going to go 3 units to the right. And now, how many degrees am I going to rotate?
120.
I'm going to rotate 120. And which way am I going to rotate?
Counterclockwise.
Counterclockwise. On this grid, each one of these lines is 15. That's just how they broke it up. You can break it up into more lines, less lines, just depends on your graph paper. So we're going to rotate around 120. So we got to go to 90, and then how many lines past 90 do I have to go?
2.
2 more. Yep. Right there. And that's how you graph the point 3, 120 degrees. So there'll be some problems on the test where you have to do that. You'll have a grid. You just click, and you'll be able to drag the point anywhere you want to put it. That's it. Any question on that one? Right, so that one had a positive radius and a positive angle in degrees. This one has a positive radius and a positive angle in radians. Radians doesn't change anything, and if you want to put it in degrees first, you can. Does anybody remember what's pi over 4 in degrees?
45.
45, yep. Okay. So from the pole, how many units am I going to go out?
5.
5. And 5 to the
Right side.
to the right side. 1, 2, 3, 4. So just put a temporary mark right around there. And now we're going to rotate how much and in which direction?
Counterclockwise, 45 degrees.
Counterclockwise, 45 degrees. On my graph, all the 45s are on the red diagonals. And that's it. That's how you graph 5, 45 degrees. All right, any question on that one? All right, next one, a little bit different. Positive radius, negative angle. So this time we're going to rotate a different way. So we're going to start by moving out how many units?
5.
5, and we're going to go 5 to the
Right.
right. 1, 2, 3, 4, 5. And now we have to rotate which way?
Clockwise.
Clockwise, and how much?
To 210 degrees.
Clockwise, 210. Well, if I go halfway around, that brings me to 180, and then I need to go 30 more. Because 180 plus 30 gives me 210. And that's where 5 negative 210 would be. Okay. Any question on that one? All right, so now a little bit different again. This time it's a negative radius and a positive angle in radians. You don't have to change the degrees, just most time people find it a little easier. But what's pi over 2 in degrees?
90.
90, yep. Okay. So can someone guide me through the whole thing?
Let me just come up there. Can I just come up there and do it?
Sure.
Alright.
So we go 3 units to the left.
90 degrees. We counterclockwise to 9.
And we end up straight down because we went 90 degrees counterclockwise.
Yep. How to erase that.
Oh, yeah, I can do that. All set. Perfect. So negative 3, 90 degrees. So let me draw how you got to that one. So we went this way, and then we went like that. Anyone think they can give me a different coordinate that still gets me to the same spot?
3,
Mm-hmm.
270.
Okay, that's another way. So that's 1, 2, 3, and then 270 would bring me around like that. How about another way?
3, negative 90.
3, negative 90. That would bring me 1, 2, 3, negative 90.
Negative 3, negative 270.
So negative 3, so negative 1, 2, 3, and then negative 270. Bring me around that way. So when you have a point in polar, there's generally more than one way to get to it. Versus if I go back to this, and I want you to get to the point 2, 3, is there any other set of numbers you could give me to land exactly on that dot? No. If you want to land on that dot, you have to go 2 to the right, you have to go 3 up. There's no other way to get to it. So in polar, there are up to 4 different ways to get to a point. If your point was somewhere on the polar axis, then there are only 3. Because if you had, let's say you had this point right here. If you're trying to describe how to get to that point, there's no rotation if you go to the right. So you can't say like go to the right and then rotate clockwise or counterclockwise. There's no rotation. So it's just 6, 0. You can go to the left and rotate clockwise or counterclockwise. So you can only get 3 ways. But in general, there's always 3, but a maximum of 4. Now if you go to the right, and let's say you say, what about if I go like this? And then I go around a couple times, and then stop. Well, then there's infinitely many ways. But I consider the 4 basic ways: right clockwise, right counterclockwise, left clockwise, left counterclockwise. Those are the 4 ways. All right, any question on that? All right, we kind of, a negative, negative, we just did that right there with the one in blue.
Yeah.
So we just did a negative, negative. Let's try this one. 0, 300 degrees. Where's that one going to end up?
In the middle. Because if it's 0, like it's not moving out any.
It's not moving out any.
So, is there really like a circle in there or something?
Well, so here's what you got to do. So you don't move out at all, but then you have to take that dot and you rotate it 300 degrees, like that. You spin the dot. So what I can do is when I used to do it on paper, I check for what's called the spin factor. So I check to see if you rotate your pencil in place, just like that. And I could use a magnifying glass and I could see like if you rotate it or not. Microscope, you know what I'm saying? I could say, yeah. 0 to 300, it just stays right in place. It doesn't go anywhere, it just pivots in place. And that will always be what 0, any angle looks like. It's always right at the origin. But how about if you reverse it? An angle that's 0 and a radius that's 1. Is that going to be right at the origin?
Yeah, it should be a 1 to the right.
Right, that's just going to be 1 to the right. So whenever you have a number, 0, it's going to be somewhere along the polar axis. Okay. All right, so any questions on those different cases? All right, so important thing to understand in polar is there are many ways to get to the same point. So what I want to do is try this one. Right. I want to try writing the point 3, pi over 6. We're going to write it 3 different ways. Okay. Let's do it this way. I want to do it where the radius is positive and the angle is between, let's do a negative angle. So negative 360 and 0. By putting it like that, I'm just saying I don't want you to go around like 6 times or something. I only want you to go up to 1 revolution, clockwise or counterclockwise, and stop. So we'll do it with a positive radius and a negative angle. We'll do it with a negative radius and a positive angle. And then the third way we'll do it, let's do it, I think I already wrote that way. Let's do negative radius, negative angle. We don't have that way. So these are all the ways that we just did it on the previous page. So the easiest way to, I think, to do it is just to draw out the original and then use the graph and just kind of trace it where you have to go. So what's pi over 6?
Probably going to be minus, but it's a 180.
I don't know. So pi is 180.
Oh, yes.
So this is 180 divided by 6.
30.
30. Yep. All right. So let's start with that. 3 to the right, and then 30 degrees counterclockwise. 1, 2, 3, 15, 30. Okay, so that's the original. Now they want us to basically write it every other way. So we went 3 to the right, and that way 30 degrees. So now let's go 3 to the right, and then we're going to go in the other direction. So what we have to do is figure out how much we have to rotate to do what I just drew in blue. Well, first of all, there's only 2 numbers you can use for r and land on the third circle. You either have to have a 3 or a negative 3. If you don't have one of those 2 numbers, you're not going to be on the third circle. So in this case, do they want us to use positive 3 or negative 3?
Positive.
Right. They're telling me they want r to be positive, and the only number that's positive and gets me on the third circle is 3. Now, how much did I rotate?
330.
Yeah, in the clockwise direction. So it's going to be negative 330. Perfect. Yep. And there's a way you can figure that out without sketching it. Like if you just subtract 360 from that number, you get negative 330. All right, let's try the second one. This time they want r to be less than 0. What number can I use that's less than 0 and it would land me on the third ring?
Negative 3.
It has to be negative 3. All right. So we're going to go left 3. 1, 2, 3. So start from there. And they want me to rotate, well, they want me to go both ways, but in this one, which way do they want me to rotate?
So each one's 15, right?
Yep. So what? Just first, which direction do they want me to rotate from that red X?
Positive.
So what direction would that be on the circle?
Counterclockwise.
Counterclockwise. So they want me to go like this. Okay. So how much would that red rotation be?
120.
So if we start from here, how much did you say?
200.
220, yeah. So this would be 180. And then we have to go 15 and 15 more. So what's that get me to?
210.
210. Okay, so that was that one. And now the last one. They still want r to be less than 0. So it has to be what number?
Negative 3.
It's got to be a negative 3. But this time they want me to rotate in the negative direction. So they want me to start here and go like that. How much of a rotation would that be?
Negative 150.
Yep. Because this section right here is 30.
Yeah.
So you've gone all the way around minus 30 degrees. So that's negative 150. Yep. And there's 3 different ways you can write that coordinate. Any question on that? So as far as graphing in polar, that's it. That's pretty much all we ever get to. All right, so the last thing we'll look at is a couple examples on converting from the system that we're using now back to what we're used to. So this is converting rectangular to polar. All right, so rectangular to polar. When you write a coordinate in I'm sorry, other way around. That's polar to rectangular. Okay. When you write a coordinate in polar, what do we call the two parts? What are the two letters we use?
In polar?
Yeah.
Radius and angle.
Radius and angle. And what do you call the two parts of a coordinate when you write it
X,
way?
Y.
X and Y. So the goal when you are changing from polar to rectangular is to change an R and a theta into an X and a Y. That's the goal. So they'll give you the R and the theta, just like that. Okay, they'll give you those two numbers. All right, so let's draw it out. Let's say we have a circle, just like that. And R, remember that's the distance to the pole. That's my R right there. And theta is how much I rotated from right there. So what we want to do is figure out how we can convert that into an X and a Y. And we're going to do that by drawing a shape. Anyone have an idea what shape we're going to draw?
Triangle.
Yeah, we're going to make a triangle out of that. And the way we're going to make a triangle is we're going to go just like that. Now, this bottom side is the horizontal distance to get from this point to that point. That's how far you travel horizontally. And what do we call the horizontal distance you travel?
The X.
That's called the X. Now, from here, you have to travel up that much to get to that point. That's the vertical distance you have to travel. And we call that
The Y.
the Y. So our goal is going to be to figure out the base and the height of that triangle. And that is your coordinate that you want, the X and the Y. All right. So you're going to be given this, and you're going to be given that, and you have to find X and Y. Let's start with X. What position is this side relative to that angle?
What position?
Yeah, what position is this side in?
It's 90 degrees. I'm lost.
Any idea?
Adjacent.
It is adjacent, yeah.
Oh.
So when we talk about positions of sides in a right triangle, your three choices are opposite, adjacent, and hypotenuse. So the X is in the adjacent side. What about, we're not doing the Y yet, but what is it?
Opposite.
Yep, that's opposite. And what about the R?
That'd be hypotenuse.
That's hypotenuse. Okay, so we're going to start with the X. What trig function would relate the side that we're going to try to find, which is adjacent, and the side that they're going to give me, which is hypotenuse? Which trig function has those two sides in it, adjacent and hypotenuse?
Cosine.
Yep, that would be your cosine. So cosine equals, what's our adjacent in this case? What did we label it as?
X.
And what's our hypotenuse?
R.
R. So now, to get X by itself, that's going to be what we want, because that's the first number in the coordinate. How would you move the R to the left side?
To the left.
Yeah, multiply each side by,
Which one are we trying to find? R, right?
we're trying to get x by itself.
We multiply it by R.
Yeah, and if you multiply both sides by r, you end up with the formula r cosine theta. So that is how you that's how you convert an r and a theta into an x value. You take the cosine and multiply by the radius. All right, now do the same thing for y. What trig function would relate opposite and hypotenuse? Sine, yep. And what would the sine equal? What over what?
R, or it would be Y over R.
Y over r. And do the same thing again. This time we want to get y by itself. And I want to know what would go in that box.
R sine angle.
Yep, r times the sine of my angle, which is, what do we call that letter?
Theta.
Theta. Yep. So those are the two formulas that you need to convert a radius and an angle into an x part of the coordinate and the y part of the coordinate. And you have to use both formulas to get both parts. And I think I wrote all that down. It's pretty much the same formulas again. So they'll give you an r and a theta in the problem, and you're going to plug in the two numbers they give you into the two formulas that are on the board. X equals r cosine theta, y equals r sine theta. Now, there's a trig function we didn't use. Anybody see which trig function we didn't use that we do use quite a bit? We didn't use tangent, and that's because tangent is going to be used to reverse this. And that we'll look at tomorrow. Okay? So tangent converts from rectangular to polar. Okay? Any questions on that? Okay. Yep, I'll take that. Thanks. Thank you. All right. So let's try a couple examples, and that'll be it. Okay, so it says to convert 6 comma pi over 6 to rectangle. All right, so first thing we want to make sure we can do is identify which number is which. In our coordinate, first, can somebody tell me which number is the r? The 6. Yep. And which number is the theta?
Pi over 6.
Pi over 6. Okay, let's start by filling those two numbers into the formula. Okay, without doing anything out yet, what's going to be my calculation to find x using the two numbers in our problem in the formula up above?
R cosine angle.
Yep, and if you fill in our values, what would it look like?
6
6,
cosine pi over 6.
6 cosine pi over 6. And if we do the same thing for y, what would our formula look like?
R sine angle.
Yep, and just filling in our numbers.
6 sine and then pi over 6.
Yes. Now, pi over 6, I think we dealt with that angle earlier. That's a 30. When you're dealing with angles that are multiples of 30 or 45, there are two special numbers that will come up. If you see the number 0.707 come up, we need to know that that is square root 2 over 2. Okay, we did that when we did the unit circle. And if you see the number 0.866 come up, that is root 3 over 2. So those come from the coordinates when we did that maybe like 3 or 4 weeks ago with unit circle. There's lots of other values on the unit circle, but those are the only two that are going to come up in the kind of problems this week. Okay. All right, so let's do that out and see what we get. So let's do, first, put your calculator in radians because pi over 6 is a radian. No need to change to degrees, you can just change the mode on the calculator. It's probably easier. For now, forget about the times 6 in front. Just do cosine pi over 6. Just see what that is. Cosine pi over 6. 0.866. What should we change that to?
Root 3 over 2.
Yeah, and if you want to double check it, you can try root 3 over 2. That's exactly what we just got. Okay, so that's one of the ones you need to know. So we still have the 6 in front. We didn't do anything with that. 6 times root 3 over 2. And if one of them comes out to not a nice number, the other one will come out nice. So the sine of pi over 6 is a very nice number. 1/2. Okay, 0.5. And we still have the times 6 in front of that. Okay. So now simplify these two to get your final result. So final answer in rectangular, 6 divided by 2 reduces to what?
3.
So that's 3 root 3, and 6 times 1/2 is how much?
3.
3. That's the coordinate that they gave us, converted into rectangular. And if you want to see what that is as a decimal, 3 root 3 is about 5.2. So that's about what it is, rounded off. All right, any question on that? So what you can kind of do on the smart board, you can't really do this in your notes. But if I graph the point 6 pi over 6, 1, 2, 3, 4, 5, 6, 15, 30. Does everyone agree I put it in the correct spot? 6 units right, and then I rotated 30 degrees. I can leave that point right where it is, and if I drop a rectangular background behind it, it should look like that point is a little more than 5 units right, and exactly 3 units up. So let's try it. That point will stay right where it is. Let me find a rectangular background. Let's use this one. So we're looking for a little more than 5 units right, and 3 units up. Let's see.
Wow.
What do you think? Did it work?
That's pretty good.
Yeah. It's a little bit more than 5 units right, 5.2, and it's up 3. That's exactly where it was supposed to be. So that's how I can kind of check my answer. That's what it looks like in polar, and that's what it looks like in rectangular. And the only reason I can do that is because if I draw in these lines, the spacing on this graph paper is exactly the same as the spacing on that graph paper. If the spacing wasn't the same, that wouldn't work. But the rings are the same space, so it works. All right, any question on that? All right, so let's try this one, and this will be our last one. All right, so convert to rectangular. Because they're telling me to convert to rectangular, that means this has to be polar. What do we call this first number in polar?
R.
Yep, that's my R. And what do we call the second number? Theta. And using the formula that we had on the previous page, what is the formula for x going to look like? Filling in those numbers.
R cosine theta. Wait. For x.
So we need to be a little bit more specific with our values.
Oh yeah, -4 cosine 120 degrees.
120 degrees. So because it's degrees, I need to change the mode back again now. And then my formula for y.
-4 sine
Yep. And that's a multiple of 30, so one of them is going to come out to one of the square root answers, one of them is going to come out to probably like a half or a negative a half, okay, something like that. So it's going to be negative 4 times something, and negative 4 times something. So let's see what cosine of 120 is. So first, change your mode back to degrees. Cosine 120 gives me negative a half. So this is the one that comes out to a nice number. Okay, let's do sine 120. Okay, 0.866. What is that? Yep.
Root 3 over 2.
Root 3 over 2. Okay, so multiply. Negative times negative is a positive. And what's half of 4? 2. Okay, here, negative times positive is a negative. And you can think of that if you want to put it over 1. What's negative 4 divided by 2?
2.
Negative 2. So converting that point into rectangular, it's 2 comma negative 2 root 3. That's your final answer. And I could do the same thing. I could change that to a decimal. I could graph it. I could graph the original, and if I change the background, you'd see they line up perfect. And that's it. So that's the first part of section 5.1. So any questions on graphing or converting from polar to rectangular? So the homework, it's all evens. And you've got about 30 minutes or so left. So you can use the time. If you get that done, then there won't be any homework tonight or any homework tomorrow for you guys.